One of the main benefits of BPC Embedded is that there is virtually no restriction on the number of characteristics that can be included in a planning application. However, from a user's point of view, it is neither practical nor desired to manually plan on every characteristic. Just imagine how many columns a user will need to scroll through if there are 30 characteristics on the screen. The application would become unusable. Several other problems are also common to planning applications. Valid planning applications may not be intuitively known to the user. For example, certain products may only be available to specific customers, and we want only those combinations to be calculated and displayed in the input-ready query. The planning application might require fields that the user might not know at the time of entry, but must be calculated based on a complex set of rules. And planning may have been performed on combinations in a previous iteration that are no longer valid, and we want to delete those invalid combinations. Characteristic relationships, or CR for short, is a powerful tool to get around this problem and several others. In this lecture, we're going to do quite a lot with characteristic relationships. At the moment, volumes planning are performed on material level, but the requirement is that material group is also populated. As stated above, the user might not know what the material group is when they enter the information, or may not care. So we do not necessarily want to display the material group in the volumes planning input schedule. We will use CR to derive the material group in all manual planning and planning functions. Characteristic relationships are configured on infra provider level. So if we go to transaction RS plan and infra provider, we type in tvol A20 and edit. We then go to the characteristic relationships tab and click on create new characteristic relationship. We then have several settings that we need to set. The first is the with derivation field. So this checks whether the characteristic is derived or only check. And in our case, we're going to derive it. And then the characteristic relationship type is either attribute, exit, or DSO. We'll cover exit in the later stage, and we're going to select attribute in this case. Then we select the master data on which the characteristic relationship is built. And in our case, we're going to derive material group from material. So in this case, material will be the base of the CR. And we then check on our target characteristic is material group. And then we save. In our scenario, planning has already been performed before the characteristic relationship has been configured. This situation occurs in real planning applications, and the data in the ADSO should be corrected accordingly. BPC provides a function type to repost the existing values in the infra provider based on any rule we add or change. The steps to create the function is basically the same as for any other planning function. However, two big differences exist. The aggregation level must be built on the base infra provider, in this case the ADSO, and not the composite. In addition, the aggregation level must contain all the characteristics and key figures in the infra provider, even the automatically derived time characteristics. The aggregation level we're creating is tvol A2001 and will contain all the characteristics and key figures in our infra provider. Next, we're going to create the filter. The filter, tvol A2001 FL1, is a very simple filter and will contain only version, as we will allow our user to select one or more versions to perform the real alignment on. For our planning function, we selected the function type repost on the basis of characteristic relationships. The system will then indicate which fields are to be derived and changed by this function. We can thus have several steps of characteristic relationships in an infra provider, which can then be separately reposted in several planning functions if required. In our case, only material group is reposted. There are no further parameters to configure. I've already created the planning sequence and added the planning function, filter, and aggregation level to it. So let's run it. We're going to run it for version 100. And we can see that display says 240 records read, 240 generated, and 240 deleted. And we can see the effect on a record in the block. Here we can see that the before record has been deleted. That's the record with no material group. There's no after record indicating that it has been deleted, and a new record with the material group has been created. Let's look at the record in the DSO using transaction list cube. So I do not have database aggregation switched on. And here we can see the effect. So the original record with no material group has been reversed, in effect been deleted, and a new record with the material group has been created. Characteristic relationships are also important for manual planning. We will look at two scenarios. Manual planning where the field to be derived is in the query, and manual planning where the field to be derived is not in the query. Let's look at the scenario where the characteristic to be derived is not in the aggregation level. So in our case, we've got material, which is our source characteristic, but material group is not in the aggregation level. If we look at our volumes planning query, I have copied the values to period 1 only, but not to period 2. So if I plan manual volumes against period 2 and save, when I look at the records in list cube, I can see that even though material group was not in my aggregation level, it has been derived. Now let's simulate a master data change. So in Eclipse, I'm going to change the master data for material F10A to material group 3 and save. So with our change material group, let's plan another record. So for the same material, I'm going to plan 510,000 for period 3 and save the record. Now when we go back to list cube, we can see that we've got two original records planned against the old material group, and our new record is against the new material group. Now this is obviously not the behavior that we want from the system. We want all these material groups to be aligned. So to correct our records, we simply run our repost again. And looking at material F10A, we see that the material group has moved from 1 to 3. So if I save the records and go back to my list cube, we can see that the record has been corrected to material group 3. So the record 1 has been zeroed out and posted to material group L3. In some instances, the user might want to see the derived field in the query. In this case, I created a new aggregation level with the material group in the query. When I run this query, we can see that the material group has been derived. So for each material, the material group has been derived. However, there's still a big problem with this application. We cannot plan against this record, as the record needs to address all the characteristics for the key figure, and unit is in effect a null value. So we've got several options for 0 unit. We can hard code the unit, but this is not a solution as the units of measure may vary by material, or we can derive the unit from the material. However, when looking at the master data for 0 material, we see that we only have 0 base units of measure available. And this is the characteristic we want to derive it. But going into the system and the configuration for characteristic relationships, we see that we don't even have the option to derive the base units of measure. The reason we cannot derive is that the attribute of material, in this case 0 base units of measure, is not equal to the field in the aggregation level, which is 0 unit. So we need a programmatic solution for this problem, and that will be the topic of our next lecture.